Dear students, welcome back. In the previous session, we have discussed about the diode valve, which is a type of thermionic valves. Now in this session, we are going to discuss about another valve called as triode valve. Okay, so if you see the construction of this triode valve, so the construction is most same as that of the diode, but in addition it contains a third electrode called grid. So it is a grid and which is placed between the filament and plate. So the triode valve consists of three electrodes. One is cathode, anode and the grid, and the grid is placed in between the cathode and the anode. So as we know that the cathode is connected to the filament, so it is called as simply we can call it as a filament. Anode is called plate, and another one is the grid, which is placed in between the anode and the cathode. Okay, if you see in this pic, okay, the grid which surrounds the filament. So here you can see this is the filament, the grid which surrounds the filament. Okay, so normally the grid which surrounds the filament, it may be of a metal sheath which is having some small holes, sieve like structure. Through this holes, this grid allows some electrons to pass out of the grid. Okay, or sometimes it may be as a metal wire. Okay, so the grid which surrounds the filament may consist of a metal cylinder perforated like a sieve to allow the electrons to pass through, or more usually may be a spiral of metal wire, maybe a spiral of metal wire. So this is which is surrounding the cathode. Okay, so a lead from the grid, so here a lead from the grid is brought to a pin outside the base of the valve. Okay, so there are 4 pins are present in the triode valve. We have seen in the diode valve it is having 3 pins, 2 for filament and 1 for plate. So here the additional pin which is coming out, that is for the grid. Okay, so totally there are 4 pins, 2 for the filament, okay, and 1 for the grid and 1 for the plate, that is anode. Okay, you can see this one is the anode, isn't it? The anode is connected to this another pin. Okay, when the filament is heated, a current can be passed through the valve as in the diode in one direction only, from the filament to the plate. That means the electrons, so that if the anode is connected to positive, once this cathode is heated, the electrons are released and these electrons are negatively charged, so these electrons are attracted towards the positive end, isn't it? The same way here the electrons are also moving in one direction only. Okay, if the grid, so here the another one is present, that is another electrode, that is grid is present. If the grid is uncharged, it has no effect on the current as the electron pass through the openings and onto the anode. So what happens if the grid is neutral? That means it doesn't have any charge. It may be a positive or negative. Neither it may be positive nor negative. It is in neutral state. Then what happens? The flow of electrons will takes place same as that of the diode. Okay. So once this cathode releases the electrons, and these electrons will come out through the small openings and it reaches to the anode. Okay, so if the grid is charged negatively, from the source which is from outside. So this is the pin, isn't it? So if you give some negative charge to it, then what will happen? So here the electrons are releasing after heating of the filament. If it is negative, if the grid is negative, what will happen here? So the electrons are also having negative charge. When it reaches to the grid, the electrons will repel back. Okay, so it repels the electrons, the grid will repels the electron, so that the current is reduced in intensity, or with a stronger charge stopped completely. Okay, that means, so if you give the negative charge, it can decrease the flow of electrons, okay, or it may stop completely if it is more negative than the source of supply. Okay, yes. Next, however, if think that in the opposite way, if the grid is given to positively charged, so then what happens? The electrons can pass through. Why? Because this is also positive, it will attract electrons, so it will allows the electrons and it reaches to the anode. Okay, here the intensity of the current can be increased. Okay, that means if the flow of electrons is the intensity of the flow of electrons is greater than the charge of grid, then the flow of electrons will reach to the anode. Okay, if you see, the intensity of the current is then greater than when the grid is uncharged. When grid is uncharged, the intensity is more. If it is positive also, the intensity of the current is more. Okay, if the grid is negative, then the intensity of the flow of electrons is less. So this is the thing, this is the working of the triode valve. Okay, so the charges applied to the grid. So we have seen that the charge given to the grid is from outer source. So the source, the external source for this grid is known as grid bias, and as the grid lies closer to the filament than does the plate, the grid charge has greater influence on the flow of current than has a similar charge on the anode. Okay, the strength of the current flowing across the wall can be regulated as in the diode, okay, and by altering the temperature of the filament, and also or by altering the positive charge applied to the anode. In addition, the flow of current across the triode valve can be regulated by adjusting the bias of the grid. Okay, so if you want to increase the strength of the current which is flowing through this valve, we can, so what are the options we can increase? So by altering the temperature of the filament, that means by increasing the temperature of the filament, or by increasing the positive charge on the anode, and also the charge, so the flow of current across the triode valve, which can be regulated by adjusting the grid bias of the grid. Okay, so by these ways we can increase the strength of the current. So if you want to decrease the strength of the current, you can reduce all these things, then automatically we can decrease the intensity of the current. Okay, so if you see the uses, now you have seen all the function and the working of this triode. If you see the uses of triode valve, the triode valve has various functions in electromedical apparatus. Okay, and it is used for the production of an interrupted direct current, and which helps in other muscle stimulating currents, okay, and also helps in muscle stimulating currents, okay, and in addition with that of a condenser and an inductance for the production of high frequency currents. So it helps in the uses of triode valve. It is used for the production of interrupted current and other muscle stimulating currents, and it is used for the production of high frequency currents in addition with a condenser and inductance. It is not used as a rectifier, but it rectifies the current which is passed through it. So, and because of its regulating the flow of electrons, so it can be used as a switch also here. Okay, so these are the uses of triode valve. Okay, in the next session we are going to discuss about the semiconductors. Thank you.